Hey, what's happening? Who's ready for a stream? It is kickoff time. This is episode 11. Today we're going to talk about, we're not going to talk about what you see on the screen, but we will a little bit. But today we're mostly going to focus on using reinforcement learning to train a robot. So we have a robot here, and this little robot goes around and cleans floors for us, which is awesome. We've trained it to look at pictures. We've trained it to identify objects and faces and people. And we're kind of got it where we can identify, lane lines like an autonomous car would. So we've got it where it can look at baseboards and see how close it is to a wall, for example. We'll take a different approach today. So today we're going to work with AWS RoboMaker. So I think we've worked with this before. If not, I've done it on another stream that you may have watched. And what I'm going to do now is go ahead and get into it and launch a development environment, because sometimes that takes a few minutes. So I'll get that started while we set everything else up. So the cool thing I like about RoboMaker, well, there's a lot actually, but one of them is the development environment. So instead of setting up your own development environment on your laptop or your computer, which can be a lot of work and take a lot of resources that you may not have as far as RAM goes or disk space, things like that, you can create your own and then work on it here. Hey Trinity, yes, more Roomba action. If you have questions, comments, put them in the chat here. We'll handle them. We'll make this a kind of a learning episode about RoboMaker, about reinforcement learning, and then about some general tips and tricks on what we want to do. So basically, we can take this RoboMaker setup, and we can build code in it. We can simulate the robot. We can even simulate the Roomba. We can simulate that virtually. And then whatever we build here and simulate, we can just transfer the code to the Roomba, which makes it really nice. So we're going to call this will be a two-part series. So I won't name it Friday Twitch, but I'll call it, let's just call it our RL environment. So when I was a kid, my mom would spell, or she would pronounce minute as minuet. And so on a spelling test, I missed it, M-I-N-U-E-T. That's how I spelled it, because it's how she pronounced it. So since then, I've kind of learned to spell things by sounding them out. So environment. All right, so we're going to go with Ross Kinetic on this one. The code I'm going to use today probably works with Melodic, which is a newer version, but we're going to go with Kinetic because I know it works for sure on that. For instance type on this one, if you want to follow along, you're going to pick an M4X large, and then networking. So I'm going to pick this Robotics Workshop VPC that I've created. It will work for you in your default VPC. So you can see I have a default here. In fact, let's just do it in default. That way you can see how it works. Subnets, just pick a subnet that you already have. So in your region, you want to go to US West 2, which is Oregon. That's where RoboMaker is available. It's there in a few more regions. Let's see. So it looks like several now. So if you're overseas, there's 4 there, and there's 3 over here in the US. But pick one of those. I'm going with Oregon. Then click Create. And we'll give that some time to create. It should take about 2 to 3 minutes. Okay, so let's let that go, and then we'll talk a little bit about reinforcement learning. So reinforcement learning is just basically teaching our robot to do something by rewarding it for its actions. So if you can imagine, like, the classic example of reinforcement learning is this taxi system where there's this grid, and in the grid there are different spaces. We call this an action space. So imagine like a 16 by 16 grid. They're each space is a square, and the taxi starts in one and can move, and its goal is to get to a rider in a different square. Well, in the other square, some of the other ones are lanes, or there are walls, there are barriers, and so the little robotic taxi is going to take a step forward or left or right or backwards, whatever it might be. That's called its action set, the list of actions it can do. So imagine forward, reverse, left, and right. And then if it hits a wall, it might get a very tiny reward, but if it goes straight, then it might get a bigger reward. And it accumulates its rewards until it says, oh, I know how to get a good reward. And finally, when it gets to the person, that's a very big reward we would give it. So it knows how to maximize after a lot of iterations. I'm talking lots of iterations. It depends on the size of the action space, that 16 by 16 grid, and then how many actions you have. But it eventually will learn by itself to get to the rider. So we're going to do something similar here. We're going to build a reinforcement learning model that we can put on the robot, and we'll teach it to go to something. And so once it learns it, we'll just copy that model. We can copy it to this robot, or we can have it hit it directly over the network and run inference against the model and make decisions all by itself. Okay, so we are back in RoboMaker. Yes, we're rewarding a robot. Trinity, what should we reward it with? We can reward it with points, but do you remember the video with the Alexa gadgets, the elephant that you fed a little Lego elephant little green leaves to. You know what, this robot, we could reward this robot with dirt. It loves dirt and dog hair. You should see this when it runs for a while and the brushes pick up the dog hair in my house. It's pretty cool. All right, so Pavlov's Roomba. I like it. It's not a bad idea. I wonder if... that's funny. We have to think about Pavlov's Roomba. That's good. Okay, so here's what you want to do. If you want to follow along, build your environment, then we're going to go to resources. Now, there are a lot of samples. Well, a lot. There are 6 of them. I think we've covered a few of these before. We're going to go with object following and reinforcement learning. We're going to change it up a little bit over the next... This is going to be a 2-part series because it will take hours to train this model. Once we get the code where we want it, it'll take hours to train it. So I'll let that run before the next episode, and the next episode we'll see the results of it. So what's happening here is it's going to GitHub. So you could actually do this without RoboMaker if you wanted to. It's going to GitHub. It's downloading a package. It's updating dependencies. Just ignore these. It's fine. This covers it all. Now, this does get a little bit heavy. This README gets a little bit heavy and a little bit, I wouldn't say confusing, but it gives you usage without RoboMaker and with RoboMaker, but it puts it all in the same README. So if you were to follow this line by line, you'd get a little confused. So make sure if you're doing that, you either follow with RoboMaker or without RoboMaker settings. All right, so we're gonna let this download. This shouldn't take too much longer. While it is, let's just go. I want to show you Alexa blogs. So I don't know if you've read this lately. This is pretty neat though. This is how to set up Alexa account linking with Cognito user pools. Cognito user pools, if you're a developer and you haven't used these yet, you will love it. If you've ever gone through and built an app, either a mobile app or a web app, and had to deal with user settings, so like user login, user forgot password, user create account, things like that, you know how time-consuming it is. Like in Rails, if you're building a Rails app, there's a good plugin called Devise that takes care of it for you, a lot of it for you. So it'll let you send out the emails that when someone forgets their password, it'll lock out an account after so many bad attempts. So that's one. I think there's a good one for Node that I'm drawing a blank on. There's a good one for Python, but there's probably none as good as Devise. But Devise doesn't even do everything that Cognito user pools do. So Cognito user pools will let you, let me show you a quick demo. Cognito user pools, just while this is building. So it's still downloading the package and updating all the dependencies. The dependencies are here in this folder, so it's getting all the latest versions. So user pools will let you basically use social sign-ins, so you can log in with Amazon, Google, Facebook. It will do just a phone number based authentication. So if you have an app like, what is it? Maybe WhatsApp uses just phone number only, for example. Then you can build that in, but it's so easy to do it. And then it manages all of your users in this nice pool. Well, now you can also use account linking in Alexa and manage all of your user accounts with account linking. So if that's something you need for your Alexa skill, be sure and check that out. All right, so that succeeded, which is great. What I want to do is just go ahead and I'll go ahead and launch this. So go to run and then go to the work. Actually, before we go to the workflow, we have some settings we have to update. So this RoboMaker settings has all types of settings you'll need to make this work. So some of them are an IAM role, for example, or a S3 bucket. So I know we need an S3 bucket. Let's create that now. Let me see if you can see this. Not really. You know, with RoboMaker, it is tough to blow up the font, so I'm not going to blow that one up for you. AWS S3 make bucket S3. We're going to call this, we'll call it Jeff9 RL environment. And the reason I'm putting Jeff9 at the front is because these are globally unique. So there's a chance no one's ever thought of RL environment for a bucket name, but just to be safe, I put my name in front of it. So now I'm going to take this and put it anywhere it's asking for S3. Actually, I don't need this S3 portion in front of it, so we'll just say Jeff9. All right, there we go. Let's go back to S3 bucket. And I'm just going through all of these and making sure we're good there. Okay, we've got that. Let's go and look for any more braces. Okay, there's one, our bracket model S3 bucket. We want to put that there. Region of the S3 bucket, we just created that in US West 2, so I'll put US West 2. Bucket name for job output. Again, I'll keep everything the same bucket. Okay, the IAM role ARN. Let me show you where this is. So we're going to load IAM, which is Identity and Access Management. And we're going to go to roles. And a role ARN will usually get created when you create a RoboMaker environment. So let's just look for RoboMaker. RoboMaker. All right. I've got quite a few because I've done a lot of RoboMaker things. You'll probably have one that says RoboMaker deployment role or RoboMaker simulation role. So let's go ahead and use, let's see, I think this one will be the one we want. Yeah. So I'm going to pick RoboMaker simulation role and just copy this link. We'll go back to RoboMaker, or sorry, we'll go to the environment. Let's close this. Okay. We'll paste this role here. And security groups. Okay, so security groups are under EC2, so we'll go to EC2. These are all things I don't think the README walks you through, so you'll need them. If you get lost when you're doing this yourself, you can just reach out to me and I'll help you get past it. So security group is, let's look at the VPC we're in. So I put it in the default VPC, so I'm going to go here. We're going to need this VPC value also. So go to your default VPC, which is this one. I'm going to copy this. This is what I need. And let's go ahead and go back to this and look for VPC. VPC config. Okay, I don't need that necessarily, but I do need it to get to the subnets. So I'm going to go to subnets. I'm going to filter by that VPC ID. And here are the subnets. So I'm just going to pick 2 subnets. That's all it really just needs one, I think, but I'm going to pick 2 different ones. Copy this here. And then we'll go paste it right here. And then we'll grab one more right here. Let's see. I always get lost in AWS. Yeah, there are a ton. When I first started, I've been here about 5 years. When I first started, I think there were 56 services, and now there are way more. Like a lot of these weren't even, this whole section wasn't here. This whole section wasn't here. This one, maybe 1 or 2 things were here. Game development definitely wasn't here. This wasn't here. So as a solutions architect, which is my role, you're supposed to know about all of these. And then if you want to specialize, you get deep in some. So at some point, it becomes impossible to know, like get past a 100 level. So if you wanted to ask me about, Lambda, I could talk to you for too long about that. But if you ask me about AppStream, I could barely give you the marketing first sentence. And I have no idea what MSK is. Never seen MSK. So there's so many things, and so we have a lot of different specialists now that can take care of. If I run into an issue and I need MSK, whatever that is, I can usually find someone that's good at it, and then that way I don't have to get super deep in it. Okay, so back in the console, we've got subnets. We do need the security group still. So security group is here. And yeah, how are you supposed to know security groups are hidden under EC2? It's a good question. A good question I asked myself just now. Let's see. So what am I looking for? I need a security group. Default VPC security group. See this here? We're going to take that and copy it. All right. I hope that's the right one. Actually, it's this one. Here's the VPC. We need to filter by the VPC that we pasted earlier, which is this one. So I'm going to take this security group, copy it, and we're going to paste that here. All right, so let's see if there are any more templates. Yes, more. Jeff Nunn, RL environment. Region again is US West 2. Don't worry if you miss some of these. It will definitely fail. The job will fail, and it'll show you what it missed, and you go back and find it. But I've done these enough now where I'm ready for it, I think. IAM role again is going to be, let's see, IAM role, this one. And right here. Security groups again. I'm just going to copy these 2 lines. I think I can do that. Security groups and subnets. We're going to copy those and put them here. If you're just joining, hey, let's see who's here. Yeah, it's crazy. Can you tell me about Control Tower, please? I could make up a lot of things about Control Tower. Control Tower, I'm actually not making this part up, but it does make it easier to manage multiple accounts. It sounds really cool, And I guess it is if you have to manage a lot of accounts. Luckily, I only have to manage one account. But if you want to manage accounts and say, okay, account 1 can only use RoboMaker, but account 2 can use everything except for Control Tower, then you can set up accounts like that. It helps you organize building. All right, do we have any more fields to fill in? Fields to fill in. All right, I think we're good. So I'm going to save that. And now we're going to go to Run, Workflow, Build and Bundle. Now what this is doing is two things. It's doing a colcon, which is a package manager basically for RoboMaker. It's going to build all of the files, all the dependencies, and the build usually happens pretty quickly. It'll create a new folder here called Build and Install in a few minutes. And as soon as that's done, it will bundle. And bundle is taking everything, packaging up together, making a tar file. So the tar file will be copied to S3, and then the simulation looks at S3 and says, okay, I know what I need to run. I know what the simulation needs to be. It's really cool. You can share that tar file with your friends or your colleagues, so they don't have to go through the same process. So if you wanted me to, I could share this simulation tar file with you, which would give you access to run it by yourself. He knew one I picked randomly while he was scrolling through the AWS console. Yeah, I got lucky. If you had picked, let's go find out what was this other one? MKG? Is that right? MSK. Madison Square. Managed streaming for Apache Kafka. Well, I know what it is now, but I've never seen it. I didn't know we had that service. I used Kafka a long time ago, or I worked with a guy. How about this? I worked with a guy that used Kafka. And so I know it tangentially, but not very well at all. It's a streaming service. So if you have ever used Kinesis, this is kind of, I wouldn't say a competitor, but you can relate the two together. Open source Kafka. So if you're already using Kafka, this just lets you manage it, which is nice. The company I worked at where we used Kafka, we did have a lot of like real servers that ran it, and it was expensive and a lot of work to maintain. All right, let's see. Any more questions? Good there. This part shouldn't. Actually, the first time you run bundle, it does take a while. So you can see we're at 14%. So we're gonna riff a little bit until this is done. But this part is the longest part. Now, subsequent bundles won't take this long. They'll be really quick within a minute or so. But what's happening right now is taking all of our code and packaging it together. So let me show you how it works. The reinforcement learning. Let's look and see. We have SageMaker Reinforcement Learning Agent, Markov, and let's see, probably Environments Object Tracker. Yeah. So what this demo does, it puts a so right here we have the create, right? This is a create robot. A really common, popular one to learn on is called the Turtlebot. We've talked about Turtlebot on here before, but there are different flavors of the Turtlebot. So there's the Turtlebot Burger and the Waffle, and I think Waffle Pie. I'll show you those real quick while it's running. Turtlebot, Waffle, and Burger. And so in the simulation, there is one Turtlebot that starts off in the middle. So imagine we have this action space, this huge area that it has to explore. And then its goal is to get to the waffle pie or the burger. Yeah, so we have the waffle pie. You can see that? Yep. And then the simulation is trying to explore a path for it to get to the burger by itself. So as it moves around, if it gets closer to the burger, you can see this little camera on here. It can see when it gets closer. As it gets closer, it gets a bigger reward, and it finally gets the big reward by getting to the pie. But it's got to explore this huge action space, and all of these actions, I'm not sure which actions it has. If it has just more than go forward, turn, and it may not have a go backwards. So let's just say it has an action space of a turn radius, and which could be any number of degrees, and then probably go forward. So it's a lot of things it explores. It will literally just do this and, get lost in the desert basically until it finds the burger. When it moves away from the burger, it's not getting very big rewards. When it comes back, it's getting rewards. Turtlebot looks cool. It does look cool. What I like, especially with the burger, look how you can just stack stuff on it. So this is kind of the quintessential way to learn ROS, Robotic Operating System. But we're doing it with Create because I like the Roomba. I like the robot. Okay, so let's see how we're doing on this. Still going. So let's go back in here. So we look at Object Tracker, and can we give ourselves more room? Oh, we drag this line. All right, and let me blow this up a little bit, maybe. Yes. So this part does I don't like the word blow up, but it does increase in size, and then we have our little console that does it. You can make it like Pac-Man. Roomba wins since it cleans dog hair. Yeah, Roomba does win. We had people over last Monday, this past Monday, and I let the little Roomba run for a couple hours, and it did a really good job. Hey, speaking of good job, we're getting sidetracked? I don't care. Let's get sidetracked. Echo Buds. So I really got deep with these this week and this weekend. So we've talked about them before in the release roundup. We have another release roundup, by the way, coming soon. Amazon Alexa will probably post the date. But I did demo them there, and I had only used them for maybe 30 minutes. And I did like them then. But I've really gotten to use these and like them a lot more since then. So what I really like, especially if you're a walker or a runner, you're outside, or if you're doing something, maybe you're mowing the yard, something where you can't use your hands as much, they're really handy for, let me make sure I'm muted here, for saying things like, Alexa, next song, Alexa, volume up, Alexa, rewind 10 seconds. I really didn't even realize that Alexa could rewind my Audible or my audiobook or my song by a certain number of seconds. So I'm sure a lot of you knew that already. I didn't know that. But it's really handy, so I can be running, and I probably look like a crazy person because I'm saying Alexa, volume up, or Alexa, next song, but they're really handy. All right, shameless plug. I don't get any benefit from pitching those to you. I'm just telling you they're a really good product. All right, back to this. You're triggering my Alexa. Alexa, buy everything in my shopping cart. Did that work, Trinity? Oh, it was yesterday. So release roundup was yesterday. Video is going up today. Good. All right. So training image size. So what's happening here is it's getting an image of the environment. So I'll show you the environment pretty soon, but it's taking an image of that, running it through a model. And you can see like the max reward, the reward constant is 10. So that means like it's going to be taking percentages of this reward constant depending on how close or how far it is. If you've ever seen the Deep Racer League, let me show you this. This is a really good way to get good with reinforcement learning too. Here we go. I don't want this part. I want schedule and standings probably. Yeah, so let me show you. These are all the races that are closed. I want to see results. The London Loop. I really just want to see the map. I've seen this Carl Nab on quite a few NAB. Who is NAB? What company is that? Let me find this real quick. Deep Racer London Loop map. No, not what I want. Here we go. So let's look at this map. It's a heat map. That's pretty cool too. This is good. Someone put a lot of work into this one. Open in new tab. Oh, I guess someone on our team did. All right. I just want to see this image. There we go. Let's blow this up. So here's how reinforcement would work here. I believe, yeah, they're going counterclockwise on this one. Is that right? Maybe so. But there are different strategies you can take. So you can say, if my car, we have the distance between center line and left line and right line. So you can say, if you have a center line strategy, meaning if you want to only follow the center line because you are disqualified if you go out of bounds twice or 3 times off the track. So you can follow the center line. The robot will learn. It'll say, I've got, my speed is 10 here, and I'm going around this quarter, and because of my speed, it ejects me off the track. So it will eventually learn that, okay, I need to slow down here, but I'm going to keep following the center line because that's where I get the biggest reward. So we're giving a big reward for center line. If it's going too far, let's say if you want to take this corner at you can see my mouse, right? Yeah. If you want to really cut this corner out here, maybe you change it up to say, when I get to point, and by the way, there are points all around the track, so let's say this point is point 200. When I get to point 200, I want to be close to the edge, so I can give a bigger reward for the edge. I give a smaller reward for the inner edge. So you give rewards based on the car's position on the track. And that's basically what's happening here. We're saying if we are close to the waffle pie burger, then we're going to give more points. If we go away from it, we're giving fewer points. So how does pin blocked? Nice. I tried to order stuff for Trinity. I'm trying to be a good guy. All right. How does reinforcement learning handle things like imaginary barriers, like in the Deep Racer track? Yeah, and then you reward the robot for not going the center. Let's see. The center line gives the most reward, and the center strategy it does. You reward the robot for not going over barriers. Yeah, you just give it. a bigger reward for not going over barriers, and a tiny reward or no reward. Let me see if I can pull up one of my algorithms for Deep Racer. It's been a while since I've done Deep Racer. Definitely tried the London loop, and that's the only one I've done. These have all happened since I did it. But anyone can participate, so try this out. It's a lot of fun. All right, so let's get started. Where's that get started at? Results. I think we can just go here. Deep Racer. You reward. Okay. So it's only in US East. We'll go there. I hope that doesn't kick me out of US West too over here. I don't think it did. So bundle is still going. So still bundling. Remember, this takes a while the first time, and then this is a good sign. Means it's almost done. Let's go back to Deep Racer right here. Okay, so here are all mine. So I did London. I had a lot of different variations. I believe London G was one of my best ones. So if we go look at London G, I just want to see my reward function. Here's what I have. Oh, unable to retrieve. Maybe one of these other ones will work. London I was my last one, it looks like. It could be because I'm logged into a different account, but you would basically see, just like what we see here. Let's see, reset. I bet we can find it here. Yeah, so this is pretty close to what I'm looking for. So if the distance of the turtlebot is less than the last distance of turtlebot, this is the turtlebot we're looking for. So we're saying if the distance is shorter than it was last time, then we want to give a little bit more reward than we normally would. If the distance of turtlebot is greater than 5, done equals true. So if it gets too far away, so it's 5 units away, then it's going to say, oh, this was a terrible training session, start again. All right, we're still creating the bundle, which is fine. And then one more thing I want to show you. Yeah, we've got a little bit here. So Alexa's 5. Happy birthday, Alexa. Alexa, sing happy birthday. I'm hoping to kick off Trinity's Alexa to sing happy birthday. So there's a new, oh yeah, this I want to show you. This is cool. This might be something we can use in our robot. So query Amazon S3 like a relational database to provide fresh skill content. So like when you build a skill, and let's say we've done this before with Twitch Robot, the skill, we say things like, well, we did something last week when we built a personality into it. Things like, who's your father? Where were you born? What's your favorite soft drink? And we had those hard-coded into a text file and a JSON file. We could actually make an S3 file full of those and have a CSV. And S3 Select is a new feature, new to me anyway. S3 Select can let you say things like select column, so select favorite drink from S3 object where column 2 is greater than 0. In our case, it'd be select favorite from S3 object or our CSV file where item equals drink. So it's getting the favorite drink. So we can have a huge database and then use S3 Select to do that. And it's pretty simple to add it to your skill. Just like we've done before, we're using the Bodo client, and then we can just make this really quick call to S3. And it'll return the results. So if you need a way to do dynamic data, we've had that question before on office hours. This is a really, really cool way to do it. All right, good. So it's complete now. It's done the bundle. So what we want to do is go to simulation and, we want to go to run, launch simulation, and train model. So what's happening now is it built, when we did the bundle, let's go to source and, it's actually right here. Let's go to bundle and output tar. It built this output tar file. So what it first does, if I scroll back up here, it's copying that tar file to the S3 bucket, this Jeff Nunn RL environment bucket that we created. It's copying that there for us, and now it's referencing it for the simulation. So if I made this a public file, you could do the same thing. You could say, I want to run the simulation. I don't want to mess with bundling or doing all that stuff Jeff did. I want to be able to just run the simulation. Then that's how you would do it and share it with colleagues or friends. Alexa says, nice, keep those robots well trained, no rewards for killing humans. Exactly. And I try to get Trinity's Alexa saying happy birthday, no dice. I mean, by now, Trinity has mute turned on. There's no doubt. That's okay. All right. Simulation preparing. This takes a couple of minutes usually. If you ever want to see what's going on behind the scenes, let me show you. Go back to, let's go back to RoboMaker. And then simulation jobs. So we need to change back to US West. So go back to US West 2, and then here we go. So I've got a couple running already. I've got one preparing. So let's close a few things out so we don't have too many tabs. I want to keep that one open. That's cool. We need to think about that one some more and see if we can find a use for it. Still preparing. As soon as it says running, that's when we are in good shape. And then we can see what's going on. Not muted. I'm curious to see how creative you can be. Oh man. Yeah. I gotta think about this one. Oh, I have got one. Alexa, turn on whisper mode. Trinity, I don't know if you have whisper mode yet. It's pretty cool. I use it at night a lot. I've got a soundtrack that plays. I've got some MP3 files in an S3 bucket, and I can play them by asking Alexa to start my skill, which plays them, but I can whisper to her, and she'll say playing whatever, but it's really quiet, so no one wakes up. You know, it'd be cool to put Polly on here, like a text-to-speech on the robot. I think, yeah, this robot does have a speaker on it. It'd be cool to make that whisper, too. There's nothing, I don't want to say creepy. There's nothing more interesting than a whispering robot. A whispering robot just makes it more human. These sidetracks. Hey, Jenny. We're doing sidetracks today because, one, I have ADHD, adult ADHD, and two, we're doing a lot of waiting. All right, so simulation was created. Simulation, let's do, what do we want to do? We want to see it, right? So we go to Applications and Gazebo. There are probably at least, we have 27 minutes left. There are at least 3 more sidetracks coming. What else do we have here? All right, so here we go. So when you run the simulation, this is it. By the way, the simulation is, one of the more expensive parts of RoboMaker. So when you're done running it, just shut it down. No big deal. I'll show you how to shut it down. You can maximize it. So here goes the robot. The robot is looking, and right now imagine this. This is the action space, this whole area. So that's our action space. It's got these actions it can take, and it's moving around. Here's a pro tip for you. So you see how our robot is, it's looking for this one, but it's moving off. Go to Models, right-click on what you want to follow, and then just say Follow. So now we can follow this. So it's looking for the robot. It can't find it. As soon as it gets 5 units away, it's going to say, okay, I'm going to start over, and it's going to reset. If we want to go to, let's go look at the Turtlebot Burger. He's just sitting there all alone, really sad. He needs a friend. Whoops, where is it? Move to. There we go. Look at the poor little Turtlebot Burger, just sitting there. Didn't do anything wrong, but no one wants to talk to him. That's okay. This little buddy's going to go find him eventually. Now I'm really, way too zoomed in. Move to, I think I need to hit follow. Or we can just zoom out. So I'm just wheeling my mouse to zoom out. And then let's hit follow one more time. I'm going to have to scroll down. Maybe not. There it goes. All right, so it looks like it might find it here. We're going to give it a second to find out. Let's see. Where are the dragons? Poor little Waffle living in a boring world. Yeah. That's a good point. Let's try this in the next, because this is where I wanted to get to today, this part. Turtlebot, find your friend. I agree. Let's change the world. Excuse me. Let's see if, so you got close there. You probably got some good points. Oh, here's what we can do too. We can also look to see, let's close this, and we can look to see kind of how the points are, like the rewards are stacking up. So we can go to Simulation, Applications, and then I believe RViz will show us. If not, I think we can find we can use RQT. All right, so this is. I don't think this is it. Let's look. Let's load the other one. So we're gonna go back to Simulation Applications RQT. Did I just load that one? No, this is it. Okay. So plugins. Let's see what we can see. Logging. Let's go to the logging console. And let's see if we can get any data out of this. So, Gazebo, we don't need. Raw's out. I'm really not seeing what I need here, too. Well, I think there's a way to see the rewards that are stacking up. Let's see if Raw's Pi is in this anywhere. Raw's Pi is there. So it's knitting a node. So it's making a node called Coach. There's an odometer. There's the camera. So it's using the camera to look for the little burger buddy. Total reward. Here we go. Send reward to CloudWatch. Let's see what that function does. So CloudWatch client, it's loading CloudWatch, and then metric name, object tracker reward per episode. Yeah, I didn't mention that part. So each of these tries are just trying to find things. It's looking in the action space. It's looking at its actions, and that's all called an episode after it finishes. So we're going to go and try to find this metric. So RoboMaker simulation, object tracker per episode. So let's load CloudWatch. Table flip. These acronyms are unintelligible. Yeah. There's some weird ones for sure. Alright, so what are we looking for? We're looking for resources, events, logs. Now, let's see what we can get. Monitoring example, Turtlebot 3. I don't think this is what I needed. These are the logs. Oh, so it's looking at the picture. So that picture we saw, yeah. The picture we saw earlier, it's not a picture of the whole environment. It's just a picture of what the robot sees. And so it's looking for, I don't know if it's looking for colors. It's looking for details about what it sees. And then if it sees the little waffle burger pie, then it knows to go towards it. All right, so let's go back to this RoboMaker simulation and metric name. I wonder if I can just search for that metric name in CloudWatch. Can I do this? No. Dashboards. I'm in Oregon. That's fine. Billing, events. Is it doing an event or it's doing a session? CloudWatch, put metric data. And metric name is that. Metrics. Aha. And is that the right namespace? Namespace, yep. All right. Graph metrics, graph options, sources, simulation job ID category metrics with no dimensions. There we go. Let's just add this. Okay. So object tracker reward per episode. I'll be honest, I don't know what this exactly is showing. I think this is the reward. But I don't know how to see how many episodes it was. So if we started at 1930, which was about right, and it's about 1940, like UTC time, so yeah, right now, I think that's it. So it got 1.6K reward, then it got a 1 reward, 1.0 basically on the next one. Yeah. So we should see this. It would be really cool. So I'm going to let this run. This will take a long time. This will take hours. I'll let this run a very long time until it completely trains. And then what I'll do is show. I'm going to keep this. So we're going to call this graph rewards. Call it RoboMaker rewards graph for Turtlebot. All right. And so what I'll do is we'll do like I'll do a 1 hour or 1 day view of it. We should see it start to converge to a higher number. As it learns more, it should end up at a higher number, obviously. All right, let's go back to our little, how do we switch windows here? RoboMaker, right here. I want to close this one. I don't want to see, yeah, so I wish I could tell what episode we're in now, but I can't tell what episode we're in right now. That'd be a really cool thing. I don't know if you've used SNS before, Amazon SNS. But it's a way to send notifications, so you can send it to different kinds of endpoints, but one would be to a phone, like an SMS message. I'm saying SNS, but SNS can send an SMS message. So it would send it to your phone, and it'd be cool to have an update of each time it hits a new high reward or a new episode, just to have it text you to your phone. Trinity says, is Little Turtlebot? Yes, Little Turtlebot is going to take hours and hours. Oh, it looks like it may have just finished an episode. Let's see this. So we saw the Turtlebot disappear right there into the vast nothingness. And I think it just started over. Yeah, this blue line is the origin. It's getting close. Look at it. Let's see if it gets close to finding him now. It was that hard to find its reward. Shouldn't there be a health bar, little points graph over its head? Yeah, that'd be cool too. I wonder, look at it. It turned. You're doing so good. You were doing so good, and he turned away. It would be cool to see. So this, let me show you how this world is created and this Turtlebot's created. Because you can add things to it, and maybe, I've never done this part before, but maybe one thing you can add would be a label with rewards. I like that, Trinity. So if I go to source, object tracker simulation, I think that's what I want. Here we go, Turtlebot 3 description reduced mesh. So this mesh, these URDF files, these are the files that it uses to build what you see, that little waffle. And someone took the time to build this out. So we're looking at the Turtlebot burger. So all it does, well, not all it does a lot, but all these numbers here are, like this, for example, is the wheel left joint. So there's a wheel that gets defined, there's a joint that gets defined, there's an X, Y, and Z coordinate. So look how precise that is. And it defines where everything is, and then there are other pieces to it, like these meshes that give it shapes and colors. But you can define where everything is. So left wheel link, a left wheel link, and right wheel link, all that. Caster. You know what I'll do too, what I think would be really cool too, is before the next time, is to show you, do the same thing, or actually the model will still be trained already, but we can replace the robots inside it. So we can do iRobot create 2 URDF Zacro. Yeah, so this would be a way to change the waffle pie with the creates, and then we can have, instead of seeing this waffle roll around looking for its little buddy, we can have the robot, this Roomba, and then maybe instead of the burger, we could just do, I don't know, a water bottle or a cat. So maybe it's trying to find something. Maybe it's trying to find dogs to clean up the dog hair. But this is the Zacro file for the Turtlebot. So I think it's not quite a drag and drop. I can't just drag it into this folder, this URDF folder here. There'll be a few things to change. Usually these are specified in the launch file. So if I go to launch, this is what happens when we hit run simulation. It does this launch file. So it's looking for a few things that have to do with waffle pie. So there'll be a few changes to make, but we'll do that in part 2. That'd be really fun. I'll show you how to do that. But then what would be really cool is to, we're in this virtual world now. It'd be cool to be able to build our world. So maybe it's the house I'm in now, or maybe it's your house. You build that, and you have a real model of the Roomba and a real model of your world, and then you're letting it learn in that type of action space. So let's check on it. Let's see how it's doing. How far away is it from? So it just started a new episode, it looks like. Let's see if it gets closer to its little buddy. We're going to watch it just for a second here. I don't know what makes it decide to turn away at some point. But this is looking more promising. Yeah, Trinity says we can have dirt in the world and make it pick it up. I bet the specifications for dirt would be pretty easy. Look how close it is. Now we're whispering humans. Could your Roomba map your house and then upload it to the world? Yes. It got really close, by the way. Yeah, so you could do, let me drag it over here. You could have the real Roomba go through the house, and then, so it's got these, where's my robot cam right there? Oh, we're still in robot cam. Oh, you guys couldn't see that the whole time. Oh, sorry. It got so close. Remember the Office episode where there was this like DVD logo and it was trying to hit the corner of the TV and everyone was cheering for it? It's kind of what was happening. So Roomba, our little buddy, went right past here and then up and around. Sorry that you couldn't see that. That's okay. You didn't miss much. It'll happen again. Yeah, so this thing, when it goes around, maybe around the house, every time this bumper hits, or this bumper hits, or the little sensor picks up something, it could basically map it out. I don't have a camera on here or a LiDAR. I do have a camera. I don't have a LiDAR on here or the ultrasonic sensor, but you can even do it that way where it's spinning around and mapping it for you, SLAM style. But all right, one more thing I want to check is, let's go to CloudWatch, just see if this is updated any. So we're going to look at 1 hour. Yeah, so it's done a few more, maybe one more episode. I'm going to count these dots as episodes, and I'm not sure that's happened or that's the case, but that sounds about right. So it's going to update these. We should start seeing it trend upwards, hopefully, because it's learning a little bit like, okay, I just finished that, and I got a few more points, so I'm going to follow that same path and then try these trees that branch off of it. Okay, let's just make sure everything's running well here. Let's see if we can go to it. Move to the robot. All right. Let's zoom out a little bit, see where it is. It's going back to home. So it may have taken a big circle and come back, but it's going back to home. Let me show you, since I was on the wrong camera, but here's the third episode. So this dot right here was the third one. 1, 2, 3, 4. Did really well. So that time that you missed where it went right by it, you got a lot of points. You got 3,000 points. So that's good. Here, Turtlebot needs glasses. That's a great idea too. Have you seen the cat that wears glasses? Here's a tangent. But I'm going to tie it in. I'm going to make it a relevant tangent. Cat wears glasses for kids. Yeah, this little cat right here helps kids feel comfortable at the eye doctor. And this cat just lets you put glasses on it, and it walks around with glasses, so kids are like, oh, a cat can do it, I can do it. And the way I'll tie that in, Alexa frames, there we go. See? It's all, or Echo frames, all ties together. Has anyone tried these yet? How many episodes does it normally take before the Turtlebot knows its world? Well, it all is a function of the action space, so how big the world is, and then how many actions you have. So if you imagine, like, the most simple world would be a, like, let's just say it's a hallway. And if you think about it in just one dimension, it's just like a line. And then you've got a robot, so the action space is just one, let's just call it 10 units long. And the action space is only go forward, and the goal is to get to the end. Then it just tries go forward and at point 1, go forward at point 2, go forward at point 3. So it really depends on the size of the action space and of the number of actions you can take. So in our example, we've got a huge action space, this whole world, and our action set is basically move forward and turn. But the turn can, if you can only turn like 2 degrees, then that's a smaller action set. But I don't know what maybe it's a 180, maybe it's 360 for this. So it's being able to turn in any direction and go forward is your action set, and you're performing it in each action space. So right now it's in a different action space. Right now it's in another one, another one, another one. So it will take a long time. It'll take hours. But it's cool because it's teaching itself. So this is a neat way to train something. All right, so I'm not going to make you sit here for 8 hours, and I'm certainly not going to sit here because it's Friday afternoon. I hope everyone has a really good plan for the weekend. Look at it. Is it turning around? Maybe while we're talking here to close up, it'll start heading back. But I will let this train. We're going to continue with part 2. Part 2, what we're going to do is see the results of this. So I'm going to fire it off. And then what I should be able to do, since it knows how to find it, it says, okay, now I know how to find that object. We can move the object around. We can replace the object. We can put it in different places. And it will know what it's looking for, and it'll do its own path planning. So that'll be really fun. So we'll do that in part 2. And then there won't be a part 3. So that'll be next week. Then the next week is Thanksgiving. And we're going to do a special episode from... should I do this? Amazon Alexa, should we not say where the episode's going to be from, or should we go ahead and tell them? Here, the robot's getting close. Let's see what happens. Question. Is there a faster mode that doesn't use a GUI to show what it's doing? There are log files for sure. So it'll show you distance and score, but I'm not smart enough to read those log files, efficiently or fast enough. It's kind of fun for me to watch it. When you do the Deep Racer challenge, there's a camera view you can see where you can actually see from the camera of the Deep Racer, so it'll show you that too. Amazon Alexa, go ahead and tell them. Okay, so on Thanksgiving week, I'll be up in Boston, and we're going to do a special show from the iRobot headquarters. So iRobot, of course, makes the Roomba. We're going to talk to them about how they do things, how they see, how they move, how they map. So a lot of what we've been doing, they do it really, really well and quicker and better. So we're going to talk to them about how they do it. We'll learn a lot. It'll be a lot of fun. I think we're going to try to make, since it's Thanksgiving week, we should try to make the Roomba into a turkey of some sort. Maybe put some feathers on it, make it roll around. I don't know. I don't know what we're going to get into, but it'll be a lot of fun. If you have any ideas for the show, if there's questions you want me to ask, make sure you send them to me on Twitter at JBNunn, or show up and ask them live, and we'll answer them live for you. Awesome. Is it on Black Friday or earlier in the week? Oh, it'll be earlier in the week. So we'll do a special episode on Tuesday. So we'll send out a tweet about that. I'll get a marketing email to go out to you that have signed up for the robot mailing list, and we'll have that out. It'll be Tuesday, and then for the Black Friday, I won't be doing a show, but I think we will probably run a show that Friday that I'll be on, and Amazon Alexa will be on to answer questions on probably. So we'll have a couple of shows ready for you to go, but I'm excited about the iRobot one, so I hope you join for that. All right, we're going to let this little lost soul find its soulmate, and then next week I'll show you the results. We'll see how it finds it and how we can move around and try to trick it. It'll be a lot of fun. All right, well, if there's no more questions, I don't see any more here, then we are good to go. Thanks for joining, and I hope you have a great weekend. Bye.